Okay, so this is question number 4. So the question here is asking, well, it's giving us an equation. We have 9x plus 9y equals 2. And it's asking, first of all, find the derivative of y by implicit differentiation. And then it's asking us to solve the equation explicitly for y and differentiate to get the first derivative of y in terms of x. And then it's asking to compare the solutions from A and B to make sure that they are consistent. So first we're going to perform implicit differentiation. Oops. Differentiation. Okay. So when we're applying implicit differentiation, we don't have to rearrange or anything. We can just take the derivative as is. So let's do that. I'm going to take the derivative of both sides. Derivative of 2. Okay, so let's start. So the derivative of 9x is just 9, plus the derivative of 9y is 9, but because you're taking the derivative of y, you have to write dy by dx, since, well, this one is just 9 because we're taking the derivative of x here, right? So because it's y and it's implicit differentiation, we have to sort of signal that we're taking the derivative of y by adding in this dy by dx term. And then just the derivative of 2, well, 2 is a constant, so that is 0. Okay, so it did ask for y prime or dy by dx. Dy by dx and y prime are, I'll just rewrite it in that notation. They're equivalent, so they mean the same thing. So that means we just have to rearrange. So we have 9 y prime equals to minus 9. Therefore, y, if you divide both sides by 9, you get minus 1. So that's the answer for the first derivative of y using implicit differentiation. So going to B, it's asking to solve it explicitly now. So I'll write that. We need to perform explicit differentiation. And really the only difference is that we are going to rearrange first. So this is probably the way you normally perform differentiation if you have a linear. So let's do that. We'll rearrange for y first. Okay? So we have, this is our original equation, remember? So we have 9y equals 2 minus 9x, and divide both sides by 9. 2 minus 9x divided by 9, and this is what we get. And now, well, I'm just going to simplify this a little bit more. We have we're just going to split this fraction into 2 different terms. So 2, and then it's 2 divided by 9 minus 9 divided by 9x, and 9 divided by 9 is just 1. So I'm just going to write minus x. Okay, so now it's a little bit easier, and we're going to take the derivative of this, okay? So dy by dx, and the derivative of, here, let me write it out, so it's clear. We have the derivative of 2 divided by 9 minus x, we can perform it on each term separately. So the derivative of 2 divided by 9 is 0, and the derivative of minus x is, oh, it's moving away, is minus 1. Okay, so this gives the answer that, well, dy by dx is equal to minus 1. And remember, dy by dx is the same thing as saying y prime. So that is our answer. And if we compare, we see that we get the same thing. We've got the same thing by doing both methods, both solving it both implicitly and explicitly. So part C is just asking us to compare the solutions to make sure that they're consistent. It suggests subbing in this equation for y into well, I guess just into the derivative of y. So that would be sort of like this. Remember we had dy by dx is equal to minus 1, just right here, right? And we also said that y is equal to 2. 2 divided by 9 minus x. And so if we just sub the y in here, we can easily see that we'll get the exact same thing. Minus 1. And yeah, so we see that we get minus 1 on both sides, meaning that this solution was correct. And it might seem silly that I'm doing this because I took both things from this second part here, but we also found that dy by dx is equal to minus 1 in the first equation. Anyways, it's pretty redundant, but that is what they're looking for in the question, just to confirm that both answers from A and B are the same. So, yeah, they both give us -1. And that's all for that question. It just states here in C that since they both give the same answer of -1, therefore the derivative with respect to x can be obtained by both explicit and implicit differentiation. So just confirming what we said before. So good work. That's correct. Okay,